This is Chemistry Unit 13, Solutions. Here we're going to look at two special topics. The first special topic is called gas solubility. So based on the graph below, which shows the solubility of several gases, which you can see here, what general statement can be made about the solubility of gases as temperature is increased? So just think about our solubility graph that had solids being dissolved. Look at the difference between that graph and this one, right? So what you might notice is that as the temperature of the gas increases, the solubility of the gas decreases. So it's, for the most part, it's the opposite of solids, right? Why though? Like, why are gases so different? Well, the intermolecular attractive forces are overcome at higher temperatures. At a higher temperature, a gas can escape from the hold of the solid. Now, this video right here is a great video to help you understand what this actually means. So it's a very simple experiment of soda in hot versus cold water. So if you are interested and want a better handle on what this means, take a look at this video. It will be posted for you. All right, now the second special topic is the electrolytes versus the non-electrolytes, right? So here's a question to think about. If you're in an outdoor swimming pool and it suddenly starts to rain and thunder, why are you told to get out of the water? Any idea why that is? Well, if lightning hits the water, electricity passes through the water and the electricity could pass through you. That's why you might also be warned to not take a shower when there's a lightning or thunderstorm outside. Same concept. If it hits a particular area of the house, could be attracted to the pipes and maybe pass through the pipes where the water is being carried through the shower to you. So it is a possibility. I'm not saying it happens all the time, but it is a possibility. And why does this happen? Well, let's go back to just the pool example, right? If you're in the pool and you're being told to get out, the pool of water conducts electricity. Ions are present, and ions conduct electricity. So an electrolyte solution is a solution that can conduct electricity due to many ions being present. A non-electrolyte solution is a solution that cannot conduct electricity due to the fact that no ions are present. And here are two great videos about this concept. The first one is an actual newscast about showering during a thunderstorm. It's like debunking that myth, or is it true? And then I also have Mythbusters, which show a pretty cool experiment. They control a lightning bolt with a stream of water, so that's kind of cool. So if you know what that show is, they always do things on a big scale, so if you'd like to take a look at these two videos, they'll be posted for you. But let's just make sure you understand the difference between an electrolyte and a non-electrolyte. So some examples of electrolytes would include acids, bases, and salts. But one that you might actually be familiar with is Gatorade, because it's actually advertised as like replacing having electrolytes and replacing the salt in your body after you exercise. So maybe that sounds familiar. And some non-electrolytes would be fats, sugars, and alcohols. Now there are two types of electrolyte solutions. You have strong versus weak electrolytes. Now a strong electrolyte is a solution that conducts electricity strongly. So you can see in this image, this is a conductivity tester. So underneath it, there's a solution being placed underneath what are called two electrodes. So the solution is actually conducting electricity very strongly, and you can tell because that light bulb is very bright. So what solutions might do this? So that actually says on the label H2SO4, which is sulfuric acid, which is a strong acid. Also a strong base, something like sodium hydroxide, which is the foundation of something like Drano or liquid plumber, and then salts. So like salt water, right? That would conduct electricity, actually very strongly. Now, a weak electrolyte is a solution that conducts electricity weakly. So this would be a weak acid or a weak base or something like water. It depends on which type of water you're actually using, if it's been distilled or not, right? So if you look in this image here, this is a little more modern conductivity tester. So this is a non-electrolyte, would not conduct at all. So the light bulb is not going on at all. And then look at the difference between the second and the third picture. So the second picture is showing you a weak electrolyte. The light bulb is on, just not as strong as the strong electrolyte in that third picture. Okay, now if you'd like to see some conductivity of different solutions performed by an actual scientist who's very enthusiastic, loves what he's doing, but nonetheless, he shows some great examples of the conductivity of different solutions. So if you'd like to check that out, that'll be posted for you. All right. So why do you have electrolytes, right? So what is actually going on when they are conducting electricity? Well, we talked about ions, right? That they have ions in solution. So let's look at what ionization means. So ionization is a process in which ions form by the dissociation of a solute in a solvent. So it's that breaking up of the solute in a solvent. So look at a strong electrolyte like hydrochloric acid, HCl. If it's being added to water, look what happens. They produce this reaction produces the ions H3O plus and Cl minus, right? And it says aqueous and aqueous because they are dissolved in water. So in this case, the solvent H2O is strongly attracted to the H in HCl and breaks it apart, right? So the result is the HCl is dissolved in the H2O. And you can tell this by that AQ symbol. Okay, so this is the formation of ions. And the example used here is the strong electrolyte hydrochloric acid. So that water is attracted to the H, pulls it off the HCl, and you've now created ions, and these are dissolved in water.